Hello everyone. In this video, I will demonstrate how to join multiple tables. So we will be doing some multiple table queries, and this is the data set I'll be working on. So here we have tile distributor database, and we have these 5 tables in that database, and we have rep table, we have customer table, orders, order line, and item, and the arrow points to the many table of the relationship. So there is a one-to-many relationship between rep and customer, and rep ID is appearing as a foreign key in the customer table. And likewise, there is one-to-many relationship with customer between customer and orders, one-to-many relationship between orders and order line, one-to-many relationship between item and order line. Okay, so the one-to-many relationship simply means that one rep will represent many customer, but each customer will be represented by exactly one rep. Likewise, between customer and orders, one customer can place many orders, and each order is basically placed by one and only one customer. Okay, there is in fact many to many relationship between orders and items table, because one order may consist of many items and one item may appear in many tables. So whenever you have many to many relationship, you have to break it down into two one to many relationship, and this is what is exactly done here. So we came up with a joining table called order line, um, which serve as a conduit between orders and items. So this table will have both the primary key of the order table and item table as a primary key. Okay, or maybe this table will have two foreign keys. Okay, that's something you have to keep in mind. And I'm not here to discuss the details about the relationship ER diagram, but more on the joining tables, writing SQL to join multiple tables. So this is the one we're going to be using for all the queries that we're going to be writing using SQL developer. And one thing you have to keep in mind is that it is always better to watch my earlier videos on this topic, where I have demonstrated how to create tables and how to load information and how to write single table queries and things like that, and then come to this one, and by that you will be on the same page. Okay, so going back here, so we're gonna be doing multiple table queries. I will start with the inner join. I have those 5 tables listed here, and this is the SQL developer. Let's do the first one here. List the number, name of each customer together with number, last name, and first name of the sales rep who represents those customer. Okay, fair enough. So we're gonna be using 2 tables here, customer and rep, and this is the way I will write the query. I'm going to say select from, say you have customer C, and I can do inner join here. Inner join, I will say rep R on R, or doesn't matter, C dot rep underscore ID equals R dot rep underscore ID. So why I complete the from statement first, and why not the select? Because once you complete the from statement, it will give me IntelliSense that I can use to select my you know uh, fields here. So I want to select the customer number. I'm gonna say C dot customer name. We want R dot we want rep number, R dot rep first, R dot rep last. Okay, and this should do the trick. So we usually, I always want on to be on the next line, and SQL will be terminated using semicolon, and I'm using uppercase for all the command keywords and lowercase for all the user supplied values. So is it required? No. you can still do it on, like you can still use the same case, lowercase or uppercase, but this makes it more readable, and this is sort of industry standard. If you go to the industry, this is how should be coded. Okay, so if I'm gonna run this one, so you can run it here, and it gave me the error here. Okay, see, so you will often see the errors like this, but you have to read through the error and see what's going on. I'm gonna show the line number. So let's see. Rep R. So there is no rep ID, there is a rep num. So you need to know your fields very well. Okay, that's the first thing we learn here. So it's always good to expand these tables and see what kind of fields you're dealing with. Okay, so we have customer number, but we have rep number, not the rep ID. Okay, so I will run this one again, and this time it's going to give me inner join. So as you know, inner join always will fetch matching records. Okay, as I explained in my earlier video. Okay, you can this is the standard way of writing SQL. There is an Oracle way of writing SQL as well. So probably you can do the similar thing using another way. So this way we're gonna say here rep R, and then it's very common to use where clause here, where you're matching the foreign key of the child table equals primary key of the parent table, and this will produce the same result. Okay, so we're getting the same result here. Okay, so this is the way the inner joins are done. Let's do some more example. Here list the name, number of each customer whose credit is 7,500 together with the number, last name, first name of the sales rep who represented them. So I will follow this nomenclature going forward because this is sort of industry standard instead of this one. Okay, so let's do that here. It's the same thing with one additional constraint where we're gonna say where C dot, so we have credit limit, right? So we have C dot credit limit equals 7500. Okay, so it will give me those only customers. So you can have the where clause as well. Other, you could have used the same thing again. Probably I will show you quickly how you can write this way as well. So where, and I will say and operator, and credit limit equals that's one. So it will give you the same result. So two ways of writing the same thing. Okay, this is what I prefer, and this is how it could also be done in Oracle. And I'm pretty sure you should be able to execute the same with many other databases, but I would say that this is the industry standard using this way inner join. Okay, that's something to keep in mind. Let's do number 3. So here we have to do the inner join again. Okay, for every item on the order, list the order number. So we need to have the order number, item number. So let's say here in the order line table we have order number, we have item number, and we need description, right? Description and number of units ordered. So probably we will be joining item and order line table here. Okay, and fetch all the information here. So I will say here, let's say select from item I inner join order underscore line on I dot say on I dot, let's say, item number equals ol dot, I should have given alias here, ol, maybe that's the reason I'm not getting IntelliSense here, ol dot, let's say item number. Okay, so is the primary key of the parent table equals foreign key of the child table. Okay, so ol is the child table here, and I want to select, say, ol dot order number to select ol dot item number. This could also be selected from item table, it doesn't matter because we are qualifying the field name with the table name, and that's the beauty about it. So I'm going to say I dot description, and I want to fetch odd number ordered, that's coming from order line table, and quoted price and actual price. I'm going to say do we have item dot price? Yeah, so we have I dot price. Okay, and I will end this with the semicolon, so it will make the inner join between item and order line. And it will fetch all the data that you requested. Again, this is the inner join, a little more involved because we are fetching a lot of fields here, but basically the concept is same. Okay, moving on, so the let's compare the join in an exist operator. So probably we can do some of this here. Okay, so let's do this one using what we call, in operator. Okay, so first we'll do the inner join and then we'll use the in operator. So we want to find a description of item included in order number 513. So we gonna be using order line and order table because we have order number here, and we actually need item and order line. Okay, so we want to find, okay, so let's go ahead and do this. So we want to find the description of the item, which is here, description of the item, and order number is here. So we will join these two tables. I will say here, select from item I, inner join, order underscore line, OL, on, I can just copy this one here, will save me some time. And we want to find I dot description. Okay, and we want to include a where clause because this is for a particular order, where ol dot, say, we can see here, order number, order underscore number equals, this is for a particular order, right? So we will say 51623. Okay, yeah, no data fetched because we might have done something wrong here. 5623. Okay, let me think about it. Hmm. Select I dot description from item I, inner join order line on OL on I dot item number equals OL dot item number, where OL dot order number is 51623. I'm sorry for that. Should be 623 here. I don't know what I was thinking, but then you get this one, and we can write the similar thing using in operator. Okay, so let's see how we can do that using in operator here. Okay, we're gonna say here, just the one, I want to select this one, where I will say I dot item underscore number. I'm going to use in operator and put a subquery here. I will say select item number from order underscore line, okay, where order underscore number equals 51623. Okay, so let's run this one. Okay, and we're getting the same answer here. Okay, so now let's go through this one. So what it does is, first inner query will be run. So this query will be run. It will fetch the item number for the order matching this order number, okay, and replace this entire thing with the answer. Okay, so it will have all the item numbers there. Okay, and then it's gonna run the order query, and it will fetch only those description where item number is contained in that set. Okay, something you have to keep in mind. um, so this is how you would do it. If you want to simplify more, you can do that. Probably I should explain here. uh, let's say I want to also fetch here I dot item number, so that we know what item we are dealing with. Okay, so basically if you replace these three in here, you'll get the same result because that's what being fetched. Okay, so probably I can do it similar way here. Okay, but this time I will replace this query with the answers. So I'm going to say dr 67, then we have fh 24, and then we have kd 34. Okay, and this should produce the same result because that's what this query is doing. What it again does is, run the inner query and replace this whole thing with the answers here, and then run the outer query, and this query is going to fetch only records where item number is contained in this set here. Okay, and this is the way you can get away with this. Another thing I want to explain here is, why did we include this in single quote? Order number, why not just write it as a number? Well, it all depends on how you define those in the table. So the way I have defined those in the table is the text string. Okay, these are not defined as a number data type, they are defined as a string data type, and that makes sense. So if you have any field on which you will not perform any calculation, you better define it as a text. And for that, watch my earlier videos, and you should be able to see it there. Okay, so this is how you would do it here. I don't need item number here, so let's let it be like that. So let's go to the next one. Okay, using exist operator. Now this is where we're gonna see the use of what we call correlated subquery. Okay, but let's do the traditional way first. So we want to find the order number, order date for each order that contains item. So order number we have here, right? Order number, order date, and for each item FD11, so item number, so we order number is here in order line as well, so we don't need these two tables here. I'm going to minimize them, don't need this one here. Okay, so let's do that here. Typical inner join, select from, say, orders O, inner join order underscore line o ol on o dot order number equals ol dot order number. Okay, and we want to select o dot order number o dot order date. These are the two fields we want to select. Okay, and we need to have where clause where ol dot item number equals fd11. Okay, okay, so let's run this one. So we have two records matching this one. Okay, this is the typical inner join. Okay, but we can also do this using existing operator, which is a sort of correlated subquery. Okay, so let's do that here. So I will say that this much is going to be common. Okay, orders O, and then I'm going to say where I'm going to use exist operator. Exist. I will explain what it means. So I'm going to say here select. Let's say I want to select all the records. Okay, let's say from order underscore line OL. Okay, where, see how am I connecting the inner query with the outer query here. So this is the outer query order number, order underscore number equals OL dot order underscore number. Okay, and then you have this one here. Okay, so let me first run this one and then I will explain what it means. So we're getting the same result here. Now let's go through this one. This is also known as correlated subquery. Now what it does is for every record that is fetched using the outer query, okay, this inner query is run once. So it will go ahead and fetch the first record and replace the order number that you found here in the outer query in the inner query here, and try to fetch the matching record. Now if it fetches any matching record using the order number here in the outer query in the inner query here, so we are using this outer query order number and sort of connecting it with our order line number here, which is the inner query. If there is a matching here, if there are any matching records here, this query will fetch uh, either one or more than one if there are matching records. Okay, in that case this statement will return true. Okay, if there are no matching records, then this entire statement will return false. So basically it's returning true and false. Okay, it's not doing anything else. If there are matching records, even one of them, even one or more than one, then it will return true. If there are no matching records, then this inner query will return false. And if it returns true, then the outer query will fetch the matching records. That's all it does. Okay, so if you run this one, it takes the order number 51614, replace it here, and found that okay, there is one matching record for this item, and it returns the true, and this record is printed here. Likewise, it does it for the second one. So this is how you use the exist operator. Okay, moving on, using subquery within a subquery. So it's like nested subqueries. Find the order number, order date. So we have order number, order date for each order that includes an item located in warehouse 3. So we will be connecting these 3 records here. Okay, could be done using an inner join. So let's do the inner join first. Select from, say, order O, inner join, order underscore line OL on. Oh, probably we can just continue here. Okay, on O dot order underscore number equals OL dot order underscore number. Okay, then we can inner join this one again. Inner join the result of this join here with item table called hi on, we're gonna say OL dot item underscore number equals I dot item underscore number. Okay, and we want to fetch, let's say O dot we want to fetch O dot order number and O dot order underscore date. Okay, but this we want to do it for a particular right storehouse. So I dot, so we will say where I dot storehouse equals 3. Okay, so this is a typical inner join and giving me an error here. So we have orders table, not orders, misspelled here. You can see here orders. Okay, say orders table here, order line table here. Okay, it's a couple of misspellings. I'm gonna run this one and it gives me this one here. Okay, so these are the thing. Now we have to do this using inner join. Okay, so we'll just do that. I mean using in operator. Okay, so we'll say this one where I will say where O dot order number dot order number in, I will say select OL, say select from order underscore line OL. Okay, so I will say OL dot order underscore number. So we'll select that from the order line table where OL dot item num, we will use another in operator here. Okay, right here we'll say select from item I where I dot storehouse, right? Storehouse equals 3. Okay, select I dot item underscore number. Okay, so we need another closing parenthesis here. Okay, now you see that how this is gonna work. First it will run the innermost query, is gonna fetch all the item numbers matching storehouse 3, replace this one with those answers, and then it will run the second order query here and fetch all the order number where the item number um, is in that particular set, replace the whole this query with the matching order numbers here, and then it will execute the outermost query. So you are doing the same thing here, but instead of using inner join, you are using in operator, something you have to keep in mind. So again, we are getting the same answers here. Okay, let's do a little comprehensive example here. Number 7, uh, list the customer name, order number. So we need customer name, we need order number. Okay, so customer and order number. All right, order number, order date, order total, which is the product of number ordered and quoted price. Okay, quoted price. Uh, for each order where the total exists 500, assign a column order total to the column that display order total. Okay, result, order the result by order number, so we have to sort the result by order number. Okay, so this is fairly easy, can do multiple ways. Okay, uh, let's do it here. I'm just looking here, do we have okay, let's do it here. So say select from customer number, we just need customer number, not the customer name. Okay, so we can use order line and order stable. Okay, so we have customer number here. So from orders o inner join say order underscore line ol on o dot order underscore number equals ol dot order underscore number, and I want to select o dot customer number, o dot order number, o dot order date, and then we want to ol dot, let's say ol dot, we can see it here, number order, num order times ol dot quoted underscore price. Again, it has to match exact field names in the table. I'm looking here on the left side. Okay, and I want to give a name to this one. I'm gonna call this as, let's say, order underscore total. Okay, so this is the way you can give a name to the table. Okay, um, so let's run this much and see what it gives me. So it gives me all the orders, but the problem here is there are multiple orders here, right? So we want to sum. So like order 334, they have order total, so we need to sum them up. Okay, and list the total. Okay, so this is how we would do it. So here we would call it give me the sum, and now we have to use what we call grouping statements. So I'm gonna say group by, if you want to group by these three things because they are the repeating fields. If you see here, these two are repeating fields. Okay, and so we want to group we want to find the sum of these two, grouping by these three repeating field here. Okay. Okay, so this is the way it should be done. Let's run this one. So now we are getting the total here. So 334, only one total is there, but we want to only list where the total exceeds 500. When you're putting a restriction on the result of the query, like here, you're putting restriction on the sum here, you have to use having clause. You cannot use where clause. Having, we will say sum of this one greater than 500. Okay, so only fetch only those record where the sum is greater than 500. Again, we are using having clause. Where clause will not work. Where only works for the individual records, not for the aggregation. Whenever you have aggregation, you have to use having clause. If you are putting restriction on the results of the um, summarization. Okay, something you have to keep in mind. So we also want to sort this one. So we're going to say order by, let's say we want to order by order number. So it should be O dot order number. Okay, so order number should be in decreasing order, and this is what we see there. Okay, we can also do this traditional way. You know that here instead of using inner join, you can use Oracle join. It will produce the same result, but keep the order in mind. It will always be select from, where, group by, having, order by. Okay, it will always be in this particular format. You cannot reverse or alter this order. It will always be select and then from and then where, if you are not using inner join but traditional join. So and then group by and then having and then order by. That should be the list here. um, the next one is using table aliases. I guess this is the first thing, because we want to find the number, last name, first name of sales rep together with the name and number of the customer. So basically it's the first one we did here. We already did this one here. I don't know why I listed it twice here, but this is what you're doing here. Basically this is asking you to use the table aliases, which we've been using it from the first query itself. Okay, so C is the alias for customer, R is alias for rep table. Okay, and then it's going to produce the same result. Okay, now joining a table to itself. Okay, again I explained this concept in my last video. Please watch that one before you come here. Here we want to find the pair of customers located in the same city. Okay, so we want to display the customer number, customer name, and the city. Okay, so we will do like this here, fairly easy if you know what you're doing here. So select and will create from, let's say, customer C1. I can do inner join customer C2 on city, because city is a common field. We are using C1 dot city equals C2 dot city. Okay, let's do this one here. So C1 dot, I want to find the customer number, C1 dot customer name. We want to find C2 dot customer number and C2 dot customer name. Okay, let's run this one and see what we get here. So we get this result here. We see that everything looks okay except this one. You see, this is not what we want, because they are the same people. We want the pair of customers, right? So one way to solve this one here is, so again you see that Oracle by themselves, they have given the aliases. So they're calling customer here, customer one, customer number, customer one, customer name underscore one. So they're duplicate. We should have given the name here, but since we are not giving it, Oracle will do it for us. But we want to definitely take care of this one here. Okay, so okay, so here the quick trick here is we will say where I can say C1 dot customer number is, I guess C1 is all greater than, so let me use greater than C2 dot customer underscore number, and that should do the trick here. Yeah, now we don't see any duplicates here. What if we use less than? Probably it might work as well. Let's check it out. Yeah, it does give me the same thing here. It just reverses the order. Okay, so this is how you would do it. Let's do one last query before I'm gonna stop this video here, joining several tables. So let's say you want to list the each item on the order, list the item number, number ordered. Okay, so item number, number ordered, order date, then we want to find the customer number, customer name along with the last name of the ref table. So we are using ref table, customer table, order line, and order table. Okay, so we are using 4 table. It's pretty easy, just a big query. So let's do it our way. Select from, let's say we know the order here, ref r inner join customer C on o dot rep underscore number, right? So we just want to make sure we're using the rep number. Yeah, rep number equals C dot rep underscore number, right? Say inner join with the orders table, orders O where on uh, on say C dot customer underscore number equals O dot customer underscore number. So see how we are joining it here. Okay, it's very important. So we are taking the primary key of the parent table, which is the parent table here, connecting it with the foreign key of the child table, which is orders table. So because one customer can place many order, and that's the order we have here, and we will inner join this one, inner join with order underscore line OL on O dot order underscore ID equals OL dot order underscore, oh, is that order number? Yeah, see order number. Okay, number. So we are joining 4 tables: rep, customer, order, and order line. And if we want to fetch, let's see, we want to fetch OL dot item number, OL dot number order, O dot order number, O dot order date, C dot customer number, C dot customer underscore name, And we want the last one, r dot last name. Okay. Okay. Let's see. Line number 107. Rep r inner join on C. If I am using R here, should be R. Okay. This is a big inner join, and it will produce all these different results here. And again, you can do the similar query. Let's say we got 12 records here using typical Oracle way of using where statement. So from, I'm gonna say C customer here, C, we'll say orders O, order underscore line OL, where, let's say here, and and okay. So let's see. Okay. Okay. So this should produce the same result. So we got 12 here. We should get 12 here. Yeah. Okay. So this is how you would do it. Two different ways. This is more industry standard. This is more Oracle way. Both works. With this, I'll stop this video here. I will create more videos and we'll address the rest of the queries here. With this, I'm gonna stop my video here. Thank you very much for listening.